A very good morning to all. I welcome you on behalf of management and VELTECH Placement Department. It's been a very great day for you all since in this 2015. This is the first company which is coming for civil and mechanical, right? 4 companies. So I hope you all been very eagerly to get a part of this, right? So I take this opportunity to thank our panel member here. So sir is our Joel Ponambalam sir. Shakti. So give a big round of applause for them. So I hope you will be fulfilled with all your aims and goals, right? So we'll start with the program with the pre-placement talk. So I'll just hand over mic to HR, right? Thank you. Before we start, I'll just request our dignitaries to light up the lamp. Oh.
Time for 20 to 25 minutes. Then we will give you a short introduction about our company. So afterwards we will start with the written test. Alright? Okay. So may I know how many of you are from civil engineering? So majority stands with the mechanical engineering, huh? Okay. In fact, I am also a mechanical engineer. So we are very special always, right? Tough guys, right?
Yes, sir.
Okay. Sorry? Lovely guys. Oh, okay.
These are the miracles of the modern age. Graceful, they defy imagination. Bridges spanning depths of rushing water with powerful girders so slender they seem to disappear into the abutments. These are the miracles we live with and enjoy every day. And they could only have been built from steel. The strength and flexibility of steel is unsurpassed by any other structural material. Steel is light, yet it is strong enough to stretch across great distances with longer spans. Steel gives designers and engineers the ability to fulfill their most imaginative concepts with structures that would be impossible to build with anything else. Steel is not only durable and economical, it allows existing structures to be altered or expanded for new or greater uses. And because fabrication can be precisely controlled off-site, steel is fast to build, much faster than other materials, and it is buildable in any season. Steel also helps preserve the earth because it is 100% recyclable, and it can be used again and again without losing any of its original strength. In fact, more steel is recycled than all other materials combined. Thanks to the power of contemporary electric arc furnaces, this scrap metal can be transformed into high-quality steel in little more than 3 hours. When it has been fired, refined, and processed, it can become powerful beams capable of supporting modern buildings or bridge spans. This electric arc furnace, consuming about 75 megawatts of electricity, just melted about 125 tons of used cars and other forms of ferrous steel scrap in about 60 minutes. The electricity arcs between the carbon electrodes and the steel scrap in the furnace to produce a heat of molten steel. Once the scrap has been transformed into molten steel, specific alloys are added to create steel that has the exact strength and properties required for its future use. Each heat will meet the requirements of the steel specification ordered by the customer, related to the chemistry and composition. Using electronic microscopes and spectrometers, inspectors scan the steel to ensure that every piece of steel has a uniform and consistent composition. Since the introduction of structural steel shapes, improvements in materials and design methods have made a profound difference. If the Sears Tower were built today, it would require 35% less steel than when it was built in 1974. After the scrap has been melted, refined, and tested, the molten steel goes into a bathtub-like container called a tundish. The steel then moves through continuous casters, where it will be made into slabs, billets, blooms, near-net shapes, or beam blanks. In the continuous casters, the steel flows through nozzles into water-cooled molds, where it is cast into a continuous bar. When the steel comes out of the caster, it must cool to 1600 degrees in order to solidify. When the steel is to be rolled or further processed, it will be brought back up to 2400 degrees before it completely cools, thereby saving the time and energy that would be required to reheat steel at a later time from room temperature. This process, like many others in the production of today's steel, is controlled by computer-driven equipment. The steel bar then goes through a straightener, and it will emerge as the finished product. Just think, only a little more than 3 hours have passed since this steel was scrap metal. It has been transformed into high-strength steel, saving our precious natural resources and preserving the earth through the use of recycling technology. After the steel has been produced, every piece of steel in a skyscraper or bridge must be precisely cut, its holes properly placed, its pieces welded in exactly the right location. Every single bolt in the structure must be located and attached at the proper place, and all this must be exact to 1/16th of an inch, so that the steel members will fit together perfectly at the site. That's why a process called detailing is such an important and integral part of building today's complex steel-based structures. It is the detailer who must develop drawings that are so precise that they will show the fabricator the exact dimensions required for manufacturing the finished steel components that will go into the structure. To accomplish this formidable task, the detailer will take the design prepared by the structural engineer and on paper build a 2-dimension or a 3D model of the steel frame of the building or bridge. It is from this model that the detailer will generate a complete list of every member in the structure, as well as shop drawings for all the individual steel pieces. To accomplish this process, the detailer must compute the length of the beams and columns, as well as the bolts and raw materials used. The detailer must also keep track of every hole in the entire structure. If a change is made in a beam connection or in the whole of one column web, it will be up to the detailer to indicate exactly how that change will affect all the holes in those beams. In addition, if a member has been changed on the shop drawing, the detailer must also change the erection drawings that will be used in the field. All this information is developed with the help of computers, and it can be downloaded to the drill line in the shop or to the angle master to show them how to drill holes for the angles. But it's important to realize that although these critical tasks are done with the assistance of a computer, they are not done by the computer. The detailer's training, skill, and expertise is the key to the process. It is the detailer's ability to translate the engineering drawings of a large structure for the fabricator so that the fabrication shop will know exactly what must be done to prepare the steel. The detailer will also indicate the preparation, cleaning, and painting of the materials depending on its specification. If that weren't enough, the detailer may also have to consider and take into account shipping requirements, sometimes even the cranes that will be used in the field, and how those cranes will load and unload members from the truck. Before the fabrication shop actually drills and cuts the steel members, the detailer must submit his shop drawings to the engineer of record for approval to make sure that the shop drawings are fully compliant with the engineer's design. It's clear that steel fabrication plays an important role in joining steel members, even before the beams and girders arrive at the construction site. This is one reason why on-site building with steel is so much faster than is possible with other materials. At the fabrication shop, the steel is cut, punched, and pre-assembled as much as possible according to the detailer's drawings. These drawings can be used to generate computer disks that will drive the shop's fabricating machinery to cut and drill the steel with absolute precision. If cutting is necessary, the operator inputs the size and the desired length of the member. The stock lengths of steel will enter the cutting machine by conveyor. An automatic arm stops the stock at exactly the right point, and the blade cuts the steel. The piece will then be labeled and rolled out. From the cutting area, the steel members will travel on a conveyor to the next station, where holes will be drilled to make the bolted connections. Here again, these critical processes are precision controlled by computer. The machine operator inserts the disc into the computer as the member is fed through the drilling machine, pushes a few buttons, and the computer takes over. As the steel automatically goes through the machine, its exact location will be monitored by laser measuring devices, so it will stop precisely where the holes must be drilled. All of the holes will be drilled in one pass as the column goes through the machine. The operator is able to see different views of the member on a small monitor, noting the number, location, and size of holes needed, as well as the precise location of the drill bit. When the holes have been made, the member will travel on conveyor to the next station. The coping machine burns steel to cut members like a saw, or it notches the steel and makes holes. Here again, the operator inserts the proper disk in the computer to initiate the process, and the piece automatically stops at the location where the precise burning operations will take place. Usually, edges that are flame cut by the coping machine are smooth and require no additional work. From here, the steel member goes to the layout station, where angles, plates, and other connection parts are bolted or tack welded. Today, high-strength bolts and welds have made joining steel members faster, more economical, and more reliable than ever before. If the piece needs welding, it will be taken to the welding area, where the welding can be done. There are other areas in the fabrication shop where the pieces needed for joining steel members are produced. For connections that require angles, stock lengths of angles are automatically delivered to an angle machine, which will cut them to the desired length and punch holes at the appropriate locations in one pass. Torch cutting plates is another operation performed by computer-operated machines in the fabrication shop. Shearing plates, punching holes, and bending steel members are other processes that take place at the fabrication shop. The piece may require cleaning and painting before being shipped. When a piece has been through all the processing called for in the detailer's instructions, it is taken to the yard, loaded onto a truck, and transported to a job site or storage yard. Because there is often not enough space on the job site to store all the fabricated steel needed for the job, the process of delivering, hoisting, and placing steel has to be carefully planned so that the pieces will be delivered to the site in the order in which they will be erected. Erecting a steel structure is a dramatic and often breathtaking process of assembling the fabricated steel members at the site. Frequently, these pieces will have to be assembled under difficult conditions, where it is not easy to maneuver them to align the holes and make the members fit. This is why precision in the detailing and fabrication processes are so important. Typically, erection is done by lifting and placing the steel members in their appropriate positions, and then temporarily fastening them with several bolts or welds. At this point, the structure is capable of supporting only its own weight and cannot resist lateral loads. It must be temporarily braced so that it will not fall over during construction. When a worker receives a member for erection, he lines up the holes by running a pin through them. Then he puts in several bolts and temporarily tightens them with his wrench. During this process, the crane operator plays a very important role. It's his job to deliver the steel to the exact location, often without being able to see it. At those times, he must rely on hand signals or radio. When a section of the structure has been assembled, workers will permanently fasten the members with additional bolts and welds. The special wrench that these workers are using will stop automatically when the required torque is achieved, ensuring that the connections are strong. Erection of structural steel has always been challenging. Many times workers have to assemble very heavy pieces at tremendous heights, with several pounds of equipment and supplies hanging from them. They may have to walk on steel beams hundreds of feet up in the air. But the industry keeps a strict eye on safety, and safety requirements require workers to wear fall protection harnesses that help make erecting structural steel safe. The challenges of erecting steel structures aren't limited to safety issues only. Special conditions can require new and innovative techniques. For example, when extremely tall structures are being built, it may be impossible to find cranes that can reach the top of the structure from the ground. In such cases, self-lifting cranes may be used that can lift themselves as the construction proceeds. In the case of the CN Tower in Toronto, the tallest freestanding structure in the world, a mast had to be put in place over 1,500 feet in the air. Lifting and erecting this heavy steel structure safely and accurately at such a high altitude in Toronto's cold winter was a tough problem. The solution was a helicopter. After several practices on the ground where pieces of the structure were pre-assembled, a special helicopter was used to lift and assemble the mast. This solution saved over 6 months of construction time. In some cases, conditions don't allow much room for maneuvering. To construct the frame of the revolving restaurant at the top of the Space Needle in Seattle, the structure was assembled on the ground to make sure everything would fit before it was lifted and permanently assembled. Regardless of the type of structure, steel offers builders many advantages. Steel offers economy, durability, design flexibility, and simplicity. Steel can also be constructed very rapidly in all weather, and it allows structural changes and easy field repair. In addition, to protect the environment and save energy, steel is 100% recyclable. Production, detailing, fabrication, and erection. Those are the primary elements in building steel-based structures. Whether those structures are magnificent high-rise buildings or dramatically beautiful bridges, experts are required in every phase of the process. Experts who can turn scrap metal into high-quality steel. Experts who can perform the complicated detailing that will transform an engineer's drawings into the specific requirements for each beam, column, and bolt. Then there are the experts in the fabrication shop who can transform raw material into fabricated structural steel. And the experts at the construction site who can erect the steel frames that form the core strength of buildings and bridges. These skilled people are all part of the team that share the excitement of building the miracles of the modern age.
All of you know, you are familiar about drafting, right? And you also know about design. And the term detailing is something maybe new to you. Right? Detailing, have you ever heard about detailing? You may not be. Right? And after seeing this video, now I hope you may have some rough idea about what is detailing, right? So detailing is a kind of intermediary stage between design and fabrication. It differs from drafting in the sense drafting you are going to just follow the kind of AutoCAD technician. So you will be simply drawing it. You may not be bothered about design aspects. Many companies will have draftsmen, and drafting is very old. It has got a good amount of history. So many times candidates graduated in ITIs and polytechnics. They do this drafting. Engineers do the design part. Now, detailing, since it has got a mix of both drafting and you will be doing some connection design, and you also need to understand the design itself, because in now we are doing this CAD, right? So the process is like you receive the design drawings from the engineer, and you have to build the 3D model. And when you do this 3D model, when you build the 3D model, you will be building the 3D model 1:1 scale, and you will extract the drawings after completing the modeling part. Now, this model, the accuracy of the model is very important because that is what going to be reflected in the drawings. So, when you are building the model, how you are understanding the design aspects. The engineer will give some typical details, but that may not fit all the locations, particularly in terms of connections. When it comes to design, there are major, we can divide into two categories: member design and connection design. The civil engineer people, they may know about this member design and connection designs. You design the members, sizes of the members, then the connection between these members, right? So the member designs, many times the design drawings will have these shapes and the sizes. But the connections parts, they will give the typical connections, but still the detailer should ensure each and every member is properly connected and load is transferred, safely. And sometimes the engineers may not understand the procedures being followed in the particular fabrication shop. And detailer is the one who has to communicate to the engineer that the particular connection he has given, the connection detail that engineer has given is more costly, and you can propose some improvements instead of doing so we have these machines and this thing. So the detailer is a central node coordinating with the fabrication shop and coordinating with the engineer, not only with the structural engineer, also with the architect, because the structural frame should be, it is an integral part of the building itself. So you have to ensure the architectural aspects also not violated. For example, you should not have your beam protecting in some other passage or some rough example I am saying. So the architect will also be doing his set of drawings, architectural drawings. So the engineer, sometimes he may not coordinate thoroughly with the architect's output. So this is done by the detailer, and from here the actual construction starts. That means you are the goalkeeper. When you miss, it's very hard to find the errors by either structural engineer or architect, whoever it is, because it's each and every piece, going and checking each and every piece is literally impossible. So the detailer has that responsibility of making the design, conforming to the design, and also ensuring that everything goes good in the erection, fabrication and erection. The quality is in the hands of the detailer. They are doing design everything, but finally the drawing is leaving from detailer's hand. Okay, so this requires little extra knowledge of understanding structural drawings. You have to know what is the loads. Typical mechanical engineers will be doing the structural what's the mechanics of solids. Some third semesters. As a matter of fact, the third semester and fourth semester, they will carry a lot of fundamental subjects, but we may not be ready at that time. We'll miss it, many part of it, right? So the mechanics of solids, and then set of materials and similarly civil engineering people, you may have many subjects, but you'll be reading so many things about concrete and roads and all these things. Okay, we hate, obviously. Mechanical engineers, all we know is mechanics of solids, strength of materials, and metallurgy. Sometimes I don't know if you have metallurgy. Right? The fatigue creates more fatigue for us. That chapter, right? Fatigue and that some we don't understand many times. Right? So these are some important subjects which act as a foundation for doing this work. So when you talk something about load and all this stuff, you have to talk right. Otherwise, better don't talk about it. So typical ITA guys or polytechnic diploma graduates may not, they do not fit to this expectation. And again, when the engineer, he starts as a detailer, and he, along the way, after gathering a lot of experience, many times they become professional engineers. Means you will get that exposure of having dealt with many designs. So if you have the capacity, you can go to that level. Professional engineers, in the sense, the engineers, they are really licensed to design. Okay, right? So not like, and you know about this design, the influence of design. In India, we don't give more emphasis on design. Many people do not really understand what is this load, 10 kg or 1 Newton, how much it will really feel physically, 1 Newton. So kind of real feel, they learn that real feel and do some measures. Best example is last year you had that accident here in Mongolia, right? Some footing, some problem with this. And we have our customers 100% from United States, and there, you can't take it for granted. So everything is, if you screw up something, they will ensure that you are screwed up. So, so we want to ensure, do things right at the first time with the clear understanding of what we do, right? So, if you have strong knowledge in these core subjects, whether it is mechanical engineer, structural engineer, civil engineer, you can contribute to our work, right? And not only detailing, so you can also start doing any design that so this paves a way, for many opportunities. But that the real stuff is in your hand, your knowledge, your understanding. Okay? Let us see how you perform in the test and in the personal interview. We hope you will do better. Right? And I would like to give you a short presentation about our company also. We'll just run through it, and also to different parts of the state, which are some other places, jobs are. We also have our presence in US also. So we have done sending people to give project support from the customer place. We use, you see the structural frame inside? So, concrete and steel are the primary materials, in forming the structural frame of the building. And so we take this steel part. So just we are going to run through it. So these are the pictures, both the 3D model and the real photo. Our projects, normally the projects, the time span will be 3 months, 2 to 3 months. Sometimes we have projects going for 7 to 8 months also, bigger projects. It depends. And we also do some buildings addition to the existing structures, renovations. And these buildings will require a lot of coordination. Means you have to talk to the customer, the existing conditions, the dimensions of the building. structures are categorized into commercial and industrial. So commercial buildings are like shopping malls, hospitals. Industrial structures are and pipe gas. Very important. So for that, the supporting steel are the pipe gas. So we do that for industrial structures. Industrial structures, we also have a good relationship with our customers. We go